We have been living under the same roof with European paper wasps for several years now. They built their first nest 6 years ago outside our bedroom window. This year, they have built an additional nest directly in front of our conservatory window at a height that is comfortable for us.
Of course, we couldn't let this opportunity pass us by. Immediately after discovering it, we got out our equipment and made ourselves comfortable. For the first time, we were able to connect a large monitor, position the tripod and additional lighting, and observe the paper wasps while sitting comfortably in a cozy chair with a good cup of coffee on the table.
In the first few weeks, we filmed the development of our roommates every day. The initial construction was carried out by 2 queens. A little later, a third joined them.
Perhaps she was lured away from the nest near the bedroom.
She was greeted and, as a sign of welcome, asked if she was hungry.
Or was she taught the house rules right away? Anyway, from now on, there are 3 of them.
While 2 queens are out looking for food or materials, the third is laying eggs.
The egg is not laid on the bottom of the brood cell, but stuck to the bottom of a side wall. If the temperature is rather low, i.e., below 20 degrees Celsius, development slows down. At temperatures between 25 and 30 degrees, it speeds up. In our nest, temperatures were rather low for 20 days, which is why there was no significant development.
We began our observations on May 3rd, 2025. The egg was estimated to be 2 to 3 millimeters in size. It was not until June 5th that an elongated shape of the egg became apparent.
Cell division is progressing. 1 day later, the embryo had already grown again. Not only we, but also the queens are watching the development very closely.
In the first cells in the middle, the embryos have already developed into larvae and are constantly demanding food. The 3 queens are fully occupied with brood care, so further expansion of the nest had to wait.
The eggs are getting longer and thicker. The upper end is thickening, and this is where the head will form. As the eggs develop, the egg casing also becomes larger and more stable. It is hardened at the point where it is attached to the cell, providing a stronger and more secure hold.
The head is broken through the eggshell and the first tentative movements of the mouth are visible. However, a heartbeat is not yet detectable. If the food supply found is greater than current consumption, the adult wasps stick a regurgitated drop of food to one of the cell walls. This drop of food is high in protein and therefore an excellent source of energy. The larvae can utilize it completely. This is important because the larvae have developed a digestive tract but no anus. This means they cannot excrete feces.
When the weather is unstable and food cannot be obtained due to colder or rainy days, for example, it is important to have a food supply for the larvae. They shouldn't go hungry, but continue to develop every day. Incidentally, we refer to the development from egg to first food intake as the embryonic stage, and only after that is it a larva.
The first, still slow and tentative heartbeats can be seen. In order to ingest liquid food, internal organs such as the foregut and midgut are required, as well as a mouth, of course. For these organs to function properly, a regular heartbeat is necessary. Cell division progresses, the head becomes more pronounced, and the heartbeat is calm and strong. The egg membrane has also grown and continues to hold the embryo to the side wall. The head becomes more pronounced with each passing day, and the embryo darkens in color. This means that its internal organs will soon be ready to process food. At the upper embryo clearly shows how it is attached to the side wall in its egg membrane. Look, she's smiling and looks totally content, the little happiness in the wasp's nest. At first, the larvae were somewhat pale. Over time, they became darker and thicker. We feared they might burst their cell walls. She has earned this short break, 2 or 3 minutes in the warm sun on a gently swaying leaf. Taking care of her little siblings all the time is exhausting and takes a lot of energy.
And off we go again. She has found a caterpillar. She chews it up, processes it into protein food with her saliva, and takes the rest home. Her conspecifics creatures in the baby supervision and the little ones are already waiting for it. This big sister already has protein food in her digestive tract. Now she pushes the liquid part out so that it can oxidize in the air. The additional oxygen helps to break down the food components and make them usable for her.
Some researchers believe that this causes liquid to evaporate from the drop, concentrating and thickening the food drop. Others believe that evaporation cools the droplet, thereby regulating body temperature. Incidentally, it is not only paper wasps that do this, but also bees. This one is about 4 millimeters long. Or this fly. It is only 1 to 1.5 millimeters long. Its food drop is milky white. This one is slightly larger, about 5 millimeters long. Its drop is transparent.
The color of the drop varies depending on feeding behavior. Some far-sighted homeowners have replaced their lawns with flower meadows. These flower meadows are home to butterfly, caterpillars, and all kinds of other insect larvae. For the paper wasps, this is a well-laid table. They collect some of these insects, thus ensuring the ecological balance of the various species. If there are too many of one species, they are found and eaten more quickly. This prevents excessive proliferation.
A caterpillar has been found chopped up, chewed into a small ball, and brought to the nest. The food ball is often shared with the other wasps and passed around among those present. Each of them chews a piece and then expels a drop of food. This is stuck to a cell wall as a supply, or as here, fed directly to their larvae, their little sisters. A wasp has taken a short nap behind the nest. Now she is hungry and needs food to feed the larvae. However, her sister has to disappoint her. She herself has nothing left and is waiting for supplies.
Paper wasps like to build their nests in places that are protected from wind and rain. This woodpile seemed to be just right. The plastic tarpaulin protects not only the wood, but also a newly built nest. But things often turn out differently than you think. A spider thought, if I spin a web over it, I'll have a guaranteed meal.
The spider was right. No sooner was its web finished than a wasp got caught in it.
This nest was built by a very inexperienced queen. She probably thought that the warm morning sun would be good for the larvae to develop, and that in the afternoon, when it gets hot, it would be in the cooling shade.
Unfortunately, their genetic code did not include protection against rain and wind. Just a few days later, we couldn't find the nest anymore.
Perhaps Charles Darwin was right after all with his theory of evolution. The weak die out, and the strong survive. Here, strength does not lie in physical power, but in greater genetic diversity. In our nest, the first larvae have now pupated and developed into adult wasps. They are now helping to care for their new sisters. These two are telling each other where and what food can be found in the flower meadow. Taste information is transmitted via a drop of food, and the distance and direction to the food is transmitted via the antennae. We do not yet know how accurate this information is, and whether our interpretation is correct. Perhaps I will help us in the future.
Food is diligently gathered and fed. The nest had to be expanded and enlarged. The more helpers there are, the more eggs and larvae can be cared for. Even though their numbers steadily increased, they always remained peaceful towards us. We were allowed to open the window and film at any time.
Paper wasps are known for being very calm and peaceful towards humans. They prefer to search for food in flower meadows rather than at our lunch table or barbecue. The summer temperatures exceeded 30 degrees Celsius on several days. To prevent the larvae from drying out, the temperature in the nest had to be cooled down.
If one of the wasps noticed that the larvae were not doing well due to overheating, it turned into a mobile fan and created a strong draft.
When one or more sisters sprayed water into or onto the cells, the breeze provided evaporative cooling.
I've noticed that about myself too. When I sweated in the sun, my skin felt cool.
About 3 years ago, we observed this lady above a nest in our bedroom. She stood on a blind slat and cooled her home from above. After a few minutes, she began tapping the slat with her front foot. At first, we thought she was a little nervous or impatient. A worker came over, spoke to her briefly, and then continued ventilating. Then a second one came, and she was also spoken to briefly. It was only when the third worker arrived that we understood what was going on. Ventilation consumes a lot of energy. In order for her to continue her work, she absolutely needed liquid nourishment. Only with this energy drink was she able to continue performing her task.
The two workers who arrived at the nest first had brought building materials for nest construction and were unable to assist the fan.
Only when you observe for a little longer and have the necessary patience do such connections become apparent. In one of the rear cells, a larva is preparing to pupate. First, she has to hatch from the egg membrane. To do this, she comes quite a way out of her cell.
She has to pull its rear end out and then sit down on the bottom of the cell. She needs every millimeter of space for pupation.
This process takes several minutes. We have sped up the film by 800%.
Immediately afterwards, she sealed her cell with fine threads. Unfortunately, there was a lot of activity on the nest. Zooming in showed us almost only the rear ends of the sisters. We chose a slightly smaller setting and filmed for a good hour.
We show the entire process here in a strong time lapse. The whole thing again. first at normal speed, then again greatly accelerated. In reality, this sealing process also took a little over an hour.
The cell has been completely closed, and pupation, the transformation into a wasp, can begin. We will continue to observe them.
The adult sisters also monitor all the closed cells. Sometimes they look very closely. If something moves, then everything is okay. If there is no movement, they place a foot on the cell to feel whether the pupation is progressing well.
They probably perceive very fine vibrations, or possibly other characteristics that we were unable to detect through our observations. Sometimes an embryo or larva dies. You must not leave a dead larva in the cell. The larva is bitten into pieces and dragged out of the cell piece by piece. Dead embryos, on the other hand, can be removed in one piece.
This is nothing unusual for wasps. If they left the dead embryos or larvae in the cell, it could spread diseases throughout the nest. In addition, her queen could not lay a new egg in this cell. This is another reason why the cell must be emptied.
The dead embryos or larvae are valuable. They contain the protein that they have already consumed before their death. This must not be wasted, so they are eaten and distributed to the others in the nest.
Brutal cannibalism?
Wasps have neither feelings nor morals. Their genetic code contains the instruction to feed protein-rich food to their offspring. They cannot decide otherwise. Cannibalism is a very human perspective. From nature's perspective, it is a simple, logical sequence without psychological evaluation. That was a somewhat difficult topic for us humans.
Sometimes we want to bend the truth a little, reshape it, gloss over it, or even conceal it. But just because something does not correspond to our moral standards, we must not distort the facts. The nest building was actually very interesting. We only discovered the nest when several cells had already been built.
The wasp nest is built from chewed wood mixed with saliva and have properties similar to paper. They are very light, but their shape makes them stable and resistant.
Nest building begins with a small column. First, a platform is built on this column, and then the individual cells are built on top of it. As soon as the nest gets a little bigger and could tip over to the side, 2 more columns are usually added under the platform. Clever. A 3-legged chair can't wobble, and neither can this nest. Further expansion takes place in stages. First, a few cells are built, and as soon as a few workers have developed, construction continues.
Some cells are not yet high enough. They will be adjusted so that an adult wasp can fit inside. So they know that the egg first develops into a larva, which then pupates and finally develops into a fully grown wasp.
Do they know? In the sense of, I know that I know, certainly not, because that requires self-awareness. However, in the sense of, it's always been done this way, i.e., Genetic knowledge, yes. For example, we know that we need to eat, but as newborns, we are not yet aware of ourselves.
This is a topic from philosophy and psychology. We don't want to go into it any further here. Otherwise, our documentary will never end.
Back to nest building. The nest is built on pillars to prevent water from seeping in as much as possible. This construction also ensures good ventilation and prevents mold. To help them with this, we have lowered our blinds so that they have good access to the nest, but also protection from wind and rain.
As a result, we were unable to use our blinds throughout the summer. It got very hot in our conservatory. It was 35 or 38 degrees Celsius for us. While the wasps were busy cooling down outside, we were sweating inside.
In some cells, the young wasps are already visible. The final stage of metamorphosis is approaching. We wait with excitement for a wasp to hatch. 5, 10 to 20 minutes pass. We wait patiently and film the whole time. We wait and wait. Finally, the battery runs out. While the full battery was being inserted, she hatched.
Back to start. The next day, we looked for another cell with a wasp ready to hatch.
It's time. The wasp begins to cut open the edges of the cell cover. Often they cannot turn around in their cell. A quarter of the lid remains closed. They cannot hatch on their own. The older sisters keep checking to see if the exit is successful.
Two sisters watch the cell very closely. If there are any problems with opening it, they are happy to help.
We observed this before, I think it was in 2019, at the nest in the bedroom. The wasp in the cell couldn't turn around and couldn't remove the lid completely. Her older sister helped her right away. Unfortunately, we didn't have good lighting at the time.
We filmed the entire nest but did not observe it. We were probably out shopping in the meantime. It was only when we checked the films that we discovered the hatching.
But back to today's nest. We definitely don't want to miss this hatching.
Exactly. Let's see what happens.
Are the batteries fully charged?
Everything's charged.
Is the camera turned on?
Camera is running.
Are the focus and lighting okay?
Everything is set. Look, she's hatching.
Unbelievable, isn't it? She comes out, there's no greeting and no birthday party. She cleans herself briefly, and after less than 3 minutes, she begins to feed the larvae.
No breaks, no time to catch your breath, no time to look around, no time to marvel at the big wide world. Just hatch and get to work right away.
By the end of June to mid-July, nest building was complete, and the population had reached its peak. We counted around 30 wasps. Of course, some were always out foraging in the flower meadow, which is why we had to estimate the number.
The old nest in the bedroom was expanded this year and also used. Since they did not have to start building from scratch, their colony grew considerably larger. We estimated it to be 50 to 60 wasps.
At the end of September, there were still 5 wasps in the conservatory nest. These queens will hibernate and found a new colony next spring. The cycle of life continues. We removed 3 nests from previous years. This year, we will also remove the 2 nests. If the wasps use the old nests and continue to expand them, the colonies will become too large.
We also want to be able to use our blinds in the summer to keep out the heat, and in the winter nights to keep out the cold. We are curious to see if they will settle with us again next year.